Welcome back to my series on assembling the RC2014 Pro computer. As you can see, it's now complete. We've got this rather delicious backplane here with all of these headers here soldered in place, along with all of the peripheral components along the top, and these 6 modules here which comprise the beating heart of a Z80 based computer. So we're now in the testing phase, and the first thing I'd suggest you do is check the soldering. So we're going to start off with the backplane, and I think I suggested in the previous video that you could do a continuity test for shorts. I think, considering the spacing of these pins and the sheer number of them, a visual inspection will probably suffice. So I've already run my magnifying glass along all of these headers, just to check for any obvious solder bridges or whiskers that could cause an issue later on, cause a short, and thankfully I didn't find any. I think I also mentioned in the previous video about the power socket, which is here. Quite a lot of solder went into that, and there are quite large holes, and I was slightly concerned that perhaps solder could have bridged on the other side of the board to short out this power socket. The easiest way to check that is with the continuity setting on a multimeter. So I'll get my multimeter out here, set it to continuity. Now mine beeps when the circuit's closed, and knowing the way this socket is arranged, I'd expect these 2 top pins to beep because they're both connected to the outer sleeve of the jack socket, probably to ground, and the inner pin is this one. So I'd expect neither of these here to beep, because if they did, that would be a short and it would cause issues when it comes to powering the board. So it's passed the sniff test there. I think now it's time to power it up and see whether we've got any action. Before we power it up, I'm going to make sure the switch is off, which it is, I think, yeah, to the left hand side, and I need to install the jumper here. You need to install this jumper only if you're powering the board off a 5-volt source, which I will be. I'll be using the power cable, the USB power cable supplied in the kit, and that will provide 5 volts. If you are going to power it off more than 5 volts, you're expected to fit extra components on the board, including LLM 7805 voltage regulator, and that will drop the voltage down to 5 volts, at which point you will need to remove this jumper, and the current will flow from the regulator to the board, the regulator to 5-volt current. But for the moment, 5 volts off USB, jumper in place. I think we're now good to plug it in and check whether or not the voltages are flowing. So first I need to find a power source. For the moment, I've got quite a handy power source right next to the board, which is the USB ports on my PC. I'm not going to be putting much of a draw on this at the moment because I'm only powering the backplane. So let's plug that in and connect that up to here, like so. And let's see if we get any action when I flick the switch. Well, hot diggity, looks like we've got power, and it looks like I've plugged the LED in the right way, which is always good. Right, excellent, excellent. So the $1,000,000 question is, are the voltages getting through to the headers? Now, on the standard and the enhanced headers, it's clearly marked. Let's move this out of the way. Ground are these two pins here, and plus 5 volts are the two pins immediately underneath it. Yep. So you can either flick the board over and check the voltages are present on the other side, or you could simply put in a header like this. I've got a 2-pin header cut out, left over from the board. Stick it in there and see whether or not you get any voltages. So get my multimeter out again so you can see it. Set it to the 20 volt range on mine because the 2 volt range would not be enough. I'm expecting 5 volts, and bearing in mind top is ground and bottom is 5 volts. Oh, hang on, is that pushed in enough? Let's try that again. There we go, I'm getting 5 volts. So you can go through and test all of the headers to make sure they've got 5 volts. I've already done this in advance. Yeah. Worth doing, I suppose, if you want to cross the I's and dot the T's. 5 volts, perfect. Right, so we know we've got power going to the headers. So let's just put my multimeter away for the moment. Switch it off before I forget. I'll just turn this off. Disconnect the power. And now we can get on to testing some boards in here. Oh, before I forget, better remove this header pin as well. So the next thing to test, I guess, is the clock module, because I can test that in isolation. So this is the clock module here. Again, I need to jumper this, and I've checked the instructions already. I need to put jumpers on clock 1, the leftmost port, and clock 2 on the leftmost point. So the left one sets the CPU frequency to 7.3278 megahertz, and the serial port A, when that's installed, to 115,200 bits per second. And this one sets serial port B to 115,200 bits per second. Obviously you can set them to different values if you want the CPU to run slower, or you want the baud rate on serial port B to be slower, but I'll go with the manual for the moment. It's worth noting that serial port A and the clock speed are tied. You can't differentiate between them. Right, so let's get some jumpers on this. Leftmost. So it's a jump. Butterfingers. There we go. So jumper on there like so. And a jumper on here. Oh, you will go on. It's upside down, that's why it's not working. Right, let's try that the right way around. Excellent. There we go. So they're both jumpered up now. That's ready to install. Yeah, good. Okay, let's physically install the module now. I'm going to stick it the rightmost slot for the moment. Bearing in mind you've got the enhanced bus somewhere in the middle. The card will only go in one way, and that's pin 1 at the top, needs to go to pin 1 on the header. Hopefully this will go in easily enough. It will leave one pin free at the bottom, pin 40 on the header free, if done correctly. Let me just check I am doing this correctly. Yeah, that looks good to me. I'll just push it in. There we go. That feels nice and solid. That's not going anywhere fast. And it's not far off kill. It's about 90 degrees. I can live with that. My previous planning when assembling the board seems to have gone to plan, which is always a bonus. Only one way to find out whether or not this works is to plug it in and see whether or not the board contains the blue smoke. So, oh, you will go in. There we go. There'll be no visual indication this is working. There's no blinking lights on the clock board, but no smoke, no sparks, no drama. So how do we tell whether or not the clock module is doing what it should be doing? Well, I can use an oscilloscope for that. I don't think there's any other easier way to do it. So I'm going to connect up my scope and work out whether or not we have a 7.3 diddly clock signal, square wave. So I can start that process off by putting in some test points. So I need a ground, which will connect there. We know where that is. It's at the top there. And we need a clock signal. So let's check clock. So we've got ground, 5 volts, M1, reset, clock. That's right. Yep, that's the clock signal there. So before I power anything up, let's connect the oscilloscope probe. Tight squeeze this. That's ground, like so. And I said that was a clock, didn't I? There we go. So I've got ground and clock. Like that. And display my scope window. Like so, and switch it on. Let's try that hand. Okay, we're getting something. So let's fine tune this. I'll keep it on 10 volts. Put the trigger in there. There we go. That's more like it. Fantastic. That looks like a clock to me. That definitely looks like a clock to me. And I wonder what the frequency is. Let's just double check the frequency. Okay, so we should see a frequency at the bottom. And the frequency is about the clock speed, 7.37 something or other. So it looks like we've got a clock A, which is brilliant. Fantastic news. So let's just stop that for a second. And we'll just check the other clock for completeness. Right, so the other clock pin is on the enhanced bus. And just make sure I've got the right one again. Let's turn it off so I don't break anything. Oh, that's on bus acknowledge. Clock 2, cunningly, is to the left of clock. So just need to move it left onto the enhanced bus. And connect that up again. Give it some juice. Boink. No sparks have escaped. Start the scope up. There we go. We've got 2 clocks. Excellent. That's half the bottle one. Half the bottle one. Okay, you can tell who's been having a drink here, can't you? Right, that's half the battle won. Next step will be, I guess, to start connecting the other modules and see how we get on. Right, we've got a heartbeat. Brilliant. Put my scope away now for the moment. And we'll get on to connecting the rest of the boards. Remember to turn it off this time. And we can get rid of this for the moment. Keep those header pins, they'll come in handy. Job is a good one. Okay, let's connect the next board up then. We're going to just unplug the power for the time being, just to make sure. Let's do the serial module next, which is this fella here. This has got a couple of jumper positions. I've actually missed one off, which is the third one up here, but the main one we're going to be looking at is the serial port 1 or serial port 8, which we're going to be using for communicating with the PC later. Do we put a jumper on that? Let's just double check the instructions. Dual serial SiO2 module. Oh, I'll put a link to the instructions in the description, by the way. There's quite a good article on jumper settings for the RC2014 Pro. Yeah, it says 5-volt jumpers optional if using FTDI cable to power the RC2014. So that's presumably if you're powering it from the PC through here, then it's optional. But if the RC2014 is powered from the backplane, which is what we're doing, do not connect the jumper. So I'm not going to connect that jumper up. Oh, and do not connect port B clock jumper, as this is driven from the dual clock module, which we've already installed. Right, so let's get this one connected up now. Same as before, make sure pin 1 is at the top. I'll stick this next to the previous card I've installed. He said. There, it's a tight fit, isn't it? Is that right? What are we doing wrong here? Oh, one pin out. Always worth double checking. There we go. No keyways on these, so it's easy to get it wrong. Yes, yes, yes. All of those look connected. The final pin, pin 40, is left blank because these are only 39 pins wide, and all of the enhanced bus connections are connected. So let's push this one home then. Oh, that's satisfying. Yeah, that's looking pretty good. That's looking pretty tidy. Happy with that. So this is where I need to choose the image that I'm going to run in ROM. So the RAM and the ROM modules will be set up accordingly. I'm going to choose the 56K basic. So I need the RAM module first, which is this fella here. And for 56K basic, and I think it's the same for, no. Yeah, for 56K basic, looking at the jumper settings, bottom 3 are set to the left hand side. And the top one needs to be to the right hand side. Yes, that looks correct to me, looking at the diagram. Right, and thankfully I've not done that, but it says do not solder link where it says link. Right, so let's get the RAM module jumped up for 56k basic. So right hand side, left hand side, left and left. Oh, you will go in. Yeah, it wasn't going in. There we go. Just me being an oaf. So like that. Right, left, 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 left. That's it. That's all we need to do on this one. Get it plugged in. So I'm going to stick that in next. Oh, I hope this works. Again, it's an enhanced bus. So make sure that that's all connected up correctly, like so. Again, that's a nice solid. Oh, I plugged it into the wrong port. What am I like? I wasn't going to plug it in there, was I? I was going to plug it in this one. There we go. Let's try that again. Yep, that's right. Take two. Nice and satisfying click there. That's looking good. That's looking good. Right, and the ROM module next. So the ROM module is here. For the pageable ROM module, I need 1, 2, 3, 4, 5, 6, 7, 8 jumpers. Let's get these all out of the packet now. Enough in here. Nice, lovely blue colour. Right, so these are set as follows. This is the page size. Setting the page size to 8K, so presumably Microsoft Basic only occupies 8K, unlike Sinclair Basic, which occupies 16K, and BBC Basic, which I think take considerably more than that. It's about 32K, something like that. I know it's quite hefty on the Spectrum Next version we're developing. It's well over 16K. So that's setting the page size to 8K, and for the page selection, apparently I'm going to set the 8K page start at 2000 on the 64K ROM. Set the 8K page start at X 2000 on the 64K ROM. I'm sure that'll make more sense later. So I'm leaving it blank, blank, blank. Top for A13. Bottom for A14. And bottom for A15. Oh, with me. In you go. There we go. So we've got bottom, top, A10 to A12 are left unpopulated, and A13's in the upper position, A14 and 15 are in the lower position. And apparently this is the, tells you what's on the ROM, the contents of the ROM. I'll look at the website for more details on that. Right, I think that's good to go in. Make sure I get it in the right port this time. It doesn't actually matter which one they're going to be honest. It's probably just a matter of preference and access. I might end up shuffling these around at some point. So that goes in there like so. Excellent. That all starting to come together nicely. Happy with that. Happy as Larry. So finally, well, I've got 2 more boards, but I only got 1 more in order to get it up and running. It's the Z80, the turn of the Z80 processor itself. Right, this is another enhanced bus job. No jumpers, it just is what it is. So let's get this one slotted in here, like so. And all of the enhanced boards are now in place. Should I got it in right? Yep, that's looking good. That's looking good. Right. Job, as they say, is a good one. That's starting to feel quite chunky now. Whew. What do we do next? I think I need to connect it to my PC next, don't I? Right. Let me go and find an FTDI card that came in the box, and I'll get that connected up to the USB, power it up and see whether or not we've got any action. So this is the FTDI adapter, which converts USB to RS232. You can see there we've got 1, 2, 3, 4, 5, 6 pins, RTS, RX, TX, 5 volts CTS and ground. So is it clear to send? I don't know what RTS, I can never remember what RTS is. It was clear to send, receive, transmit, 5 volts and ground. So is it, I can't remember, I'd have to look it up. Clear to send, never mind. Let's just get this plugged in, we can worry about RS232 later. So this connects to the port here. Just need to make sure I'm plugging it in the right way. Let's see if there's any markings on the serial board itself. It just says port A. Oh yeah, there is one. We've got ground at the top. Okay, I think that's the tell. So that means that you can see there, top pin is ground. My bottom pin is ground there. So it means I need to invert the board so that ground and ground are connected like. Try again. So there we go. So ground is definitely connected to ground. I just need to find an USB cable that's compatible with that. I think I've got one knocking around somewhere. Double check, ground. Right. There's the scary bit now, plugging it into a PC and checking whether or not we've got any signs of life. So I guess the first thing we need to do is get this hooked up to the comms. Now I've got the cable here. Goodness knows, I can never tell you what the size of USB connector is, but it's one of those. So I'm going to connect that up to the FTDI, like so. You will go in. Put the right ones. There we go. And I'm going to connect that to my PC, USB, like so. And hopefully, with a bit of luck, I'm going to open Device Manager on my PC. We should have a new COM port up here, which is that fella there, USB serial device, COM6. So if I unplug this now. That should disappear, just to make sure it's the right COM port. Right, so we know this FTDI board is appearing on my PC as COM6. Your actual mileage will vary depending on what other COM ports you've got on your PC. I know I've got several more that are hidden at the moment for other FTDI adapters. But yeah, that's COM6. Good, good, good. So that's half the battle won. So the next step is to set this up in PuTTY so we can start to talk to it. PuTTY is a piece of terminal software that also allows you to talk to serial devices. It's my weapon of choice for this kind of thing. Other terminal software packages are available. So let's launch PuTTY up, and there we go. Right, I've already set this up in PuTTY. If I load the settings, it'll give you an idea of what settings you need to put into your terminal software. Let's load up the settings first. It's on serial COM6. The baud rate's 115,200. 8 data bits, 1 stop bit, no parity, and I've got the flow control as RTS CTS. Yep, that's looking good. Right, so I can open that now. Nothing will happen because the board's not powered, and nothing's going to talk back to it. But I should be able to open that. Let's drag the window over here. There we go. Right. Next step is to power the RC2014. So I'm going to get the power cable, which is supplied with a kit, which has got USB one side and barrel jack plug thing on the other side. So let's connect that up first. Switch is set to off. Plug that in there. Plug that into my PC for the power source for the moment. Here we go. The moment of truth. Let's switch it on. Okay. Nothing's happening so far. Let's try reset. Oh, that's good news. Okay, so we know the ROM's working and the RAM's probably working. This looks like it's going to be booting into something. Memory top. Sensor for the default, I guess. Oh, there we go. Excellent. We've got the basic board working. So let's just type a quick program in. Let's start off with a classic, hey? Microsoft Basic. Excellent. Right. Okay, that seems to be working. Obviously, I've not tested the compact flash module. What I'm trying to do is restrict the testing so that I can work out where the snags are. I think I found one snag already. Let's just stop that a minute. It's my expectation would be with the clock board that it seems to have a reset circuit on there. There's a resistor cap diode reset circuit which should hold the Z80 reset line low for a fraction of a second, a few clock cycles after the board's first powered up. But that doesn't seem to be working. So let's reset that again. The main board reset's working. Let's, there we go. Yeah, so I can reset it here with no issues. There's another reset button here. I think that's a reset button. I'll have to check the documentation. That doesn't seem to be doing anything. Okay, I'll have to double check the functionality of that, but I think that should be reset as well. That's tied into the aforementioned reset circuit. Okay, and that probably explains why there's no sign of life when it's first powered on. Yeah, the Z80 requires the reset line to be held low for a few clock cycles after power up. So I can do that manually here by pressing this button. Ideally, you want it to do that automatically when power is first applied to the board. Huh. Okay, well, that's good. The majority of the board seems to work. We've got basic up and running. Yeah, I'm quite pleased with that. There's something for me to debug, which is the reset circuit, which we'll look at some point in a future video. But yeah, there we have it. First attempt, it fires up. So we know for sure that the clock board's possibly got a fault in the reset circuit. Z80 board's clearly working okay because it's running a program. The RAM and the ROM modules appear to be working because I am running a program. And the serial I/O board's working because I can talk to it via PuTTY. Excellent. Right, so the next step is to get this booting up in CPM with this, I guess, work out whether or not the compact flash boards are working, get the final board installed. Now, in the meantime, I hope you enjoyed watching this video, and if you like what I'm doing, then please subscribe to my channel, and I will see you in the next one.